You know, it was my previous series. I had found something in it, and it was I wanted to represent it. And it's very vague, but it had a lot to do with the evolution of humanity and how we evolved. And that was the question why. You know, without it, we can't grow if we don't ask questions in our life about why and dig that way. So what I had done to represent that question in the previous series to what you see here is I developed an experiment. And the paintings carried four things: depth, movement, shape, and color. Three of those things were constants, and one of those things was a variable that changed, and that was the color. That way it gave me an opportunity to study the viewer and study myself and figure out what it is, kind of like a colored Rorschach test, if you will. Well, after a few years, I started using the data and putting it together, and I found that it was so interesting, you know, that people could see the same thing in different paintings, but the color changed, so the emotion changed. And that was intriguing, and instead of just accepting it for what it was, and oh, color is just color, and that's just how it is, I wanted to dig deeper. And that's what I had found was this series of works, represented in this series of works. So, yeah. You know, I started doing some research about what color was and how it attained to light and how our vision attached to what it was, you know. And it's interesting, Newton, for example, had found that light traveling through a prism, you know, obviously separates color. And at that time, everybody assumed that the light was manipulating the prism. Well, he did a series of experiments and found that it was actually the prism that was manipulating the light. Therefore, that's, you know, it's groundbreaking. That changes how we look at it. Light carries obviously these properties of colors and not the prism. Later on, a guy named Thomas Young, did an experiment as he observed artists and clothes manufacturers. And this is about in 1801, 1802, when he did this experiment, trichromatic theory, that you could make any color if you had three primary colors, three colors. And at that time, it was widely accepted that there were three different types of lights. Well, what he'd found that it wasn't the physics of light. It was actually the anatomy and physiology of humans that were able to interpret different colors. And that was, you know, that's like the difference between the world being flat and the world being round at that time. And later it was improved by another guy, Hermann von Helmholtz, who discovered that we have three cones in our eyes, and that's why we're known as trichromats. So the development over the years, you know, 175 years later, until widely accepted in 1970, that these pinnacles of your sensitivities in your eyes picking up the main basic three colors, and this is very broad to say, but the three cones picking up three different colors, they overlap, and to develop the process of opponent process, meaning our eyes, our visual sensitivity picks up the differences in the responses of these two cones and not just each cone as it is. So the evolution of this is really important to understand that light, thus, color, this is a wavelength at a certain frequency transmitted, given by light. And this is what our eyes perceive, and it's not necessarily, it's energy. It's stimulating the cones in our eyes that give us a perception of color, that give us this idea of color. So the process of which I work with these is, it's thin layers over and over again. What happens with light, understanding now that light is a major factor in the essence of color and how it is pure energy, light when it hits a canvas, and wavelengths reflect off of it, and some wavelengths get absorbed, and that's what you see because your eyes are stimulated to that factor. I wanted to take it into the effect of when you add thin layers and you allow light to travel through these layers, hit the back, and then bounce back and forth before it comes back out. The light gets absorbed in there longer. It stays in there longer. Between each layer, there's a little bit more light behind it, so it has a glowing effect to it. And that's important to capture that, because when I'm trying to bridge a gap between light and color, to have something as transparent of understanding and visibly as well is really important. So, and that's why to make that bridge even further, the names of all the paintings are X and Y coordinates. These coordinates come off of the CIE chromaticity diagram, which was developed in 1931. What I had found was when technology started growing, and to bridge this gap between wavelengths, and to be able to coordinate that with a code, RBG, along with the CMYK that came a little bit later. Taking those codes and being able to program them in to get that certain light is vastly important, and that's a lot of what started the Pantones, because as the World Wide Web and the world started connecting together with print work or displays and technology started coming, they had to coordinate colors between printers around the world and displays around the world, and they did that by things like Pantones, which had a code, RBG or CMYKs, and everybody around the world know that if that code is there, it means this color. So it's how everybody can communicate on the same level. So you see this growth, and that's where the diagram, that I use that diagram, so you can actually pinpoint where that wavelength in this color exists. And then the other number on there is the brightness scale, kind of the 3D, I guess you could say, that behind the deal, because white can also, and gray are on the same X and Y, but have a different brightness, obviously. So you can't really see that until you make it into a 3D graph. It's interesting, because this is all around us. This is things we know. We end up accepting the things how they are, and we forget where they come from. And it's all around us. Hospitals, they don't use tons of dark reds or tons of dark blues, because that makes patients feel hot and makes them think of fire, and then the blues make them feel cold and lonely. Fast food restaurants love red because it invigorates, hunger. Cultures around the world, revolve around color and things. And it's interesting how these things emit emotion in some way or form, and what it really ties to. The fact that it is a wavelength that stimulates your eyes, and that is stimulating an emotion or a memory of sorts, is fundamental to never let that dissipate, because wavelengths, like on every measured in nanometers between 380 and 780, is an electromagnetic spectrum that exists, which is visible light. And that exists along with gamma rays, X-rays, infrared, that's our sunburns and everything else. That's pure energy that's reflecting off the canvas. We see color, and it's really just wavelengths stimulating our eyes. And when you grasp that understanding, the world is a little different. The world is, a little bit more. You're able to evolve in an understanding, and you own that emotion at that time. So to me, that's key for people to break through. It's like saying the primary colors is widely accepted, but we now know that you can't make every color in the gamut with that. There are other 3 colors that you can mix to make it to get even more gamut of colors. But still in our educational system, that's just what it's accepted, as it is. That's why CMYK, you can grab more colors than RGB, and it's because cyan and magenta and whatnot are better attributes and whatnot. It's very odd, it's very interesting. So, but to realize that it's pure energy, actually a foundation scientific proof that this is what it is awesome. So I had to explore it and represent it in some way or fashion.